Okay, I'm picking up on question number 11 here. This video I plan to include 11 and 12. 11 asks us to use the definition for derivative, that is f prime of a is the limit as x approaches a of f of x minus f of a over x minus a. And we're being asked to use that to find f prime of 1 when f of x is defined as negative 3x squared. So, a couple of things. This is, I believe, what is called, I think this is just alternate or another definition of derivative. I don't think it had a more specific name. Notice they're giving us f prime of a and they're asking us to find f prime of 1. So keep in mind as we do this problem, our a value is going to be 1. So let's jump right in. Being asked to find f prime, instead of a, it's going to be 1. So I see a, I'm going to replace that with 1. Don't forget, you can see it was a typo in here, but don't forget to put in your steps the limit as x approaches, I'm going to say 1. And then it is of f of x, which f of x is defined as negative 3x squared minus f of a. So that's going to be minus f of 1, which is going to be negative 3. Instead of x squared, we're going to say 1 squared. And it's all over x minus a, so x minus 1. I'm going to continue along with this. I'm going to clean up that top, and that it is going to be negative 3x squared minus a negative is going to make it plus when I multiply by 1 squared, so plus 3 over x minus 1. If I continue, I see that there is some factoring to do. So the limit as x approaches 1, on top there is a GCF of negative 3 that I'm going to factor out. When I factor out that GCF of negative 3, I then have x squared minus 1, still over my denominator of x minus 1. Continuing along here, the limit as x approaches 1, and you'll notice we keep that GCF of negative 3 out front, but x squared minus 1, I'm hoping you remember that is the difference of squares. So it factors into 2 parentheses. X and x in each parenthesis, the square root of 1 is 1, and it needs to be a plus 1 and minus 1. All over, still, x minus 1. You will notice that there is a factoring common of x minus 1 that will cancel. So I'm going to cancel out my x minus 1s. And that now gives me the limit as x approaches 1 of negative 3 times x plus 1. This is what we're going to be doing to find our f prime of 1. At this point, we've done all the simplifying we can, and so we are ready to plug our value in. So as x approaches 1, that means I'm going to plug in 1 for x. So negative 3 times 1 plus 1, which becomes negative 3 times 2, which is negative 6. So we found f prime of 1 to be negative 6. Now, keep in mind, you can check yourself. If we go back up here and use our quicker methods, f of x is negative 3x squared. F prime of x then becomes negative 6x. And when you plug in 1, negative 6 times 1 is negative 6. Okay. That now takes us to number 12. Number 12 asks us to find the exact area under y equals x squared from 0 to 3 using an infinite number of inscribed rectangles. Okay, so If you recall, this is the one where we had a page full of steps. The first thing you were asked to do is to sketch a graph. And so as I sketch my graph here, my graph is y equals x squared from 0 to 3. So I'm going to draw my basic parabola here in quadrant 1 because I've been asked to go from 0 to 3. So I have 0 to 3 over there. When we're using an infinite number of rectangles, remember we just draw in a handful of rectangles to get you started. And then I kind of leave a gap and I always draw in the last rectangle. Okay. As we label this is 0 here. The first one I call x sub 1. The second one is x sub 2. My third value is x sub 3. All the way over to the end. Remember your last value is always x sub n, which means the one before it is always x of n minus 1. Now, in this case, we were asked to do inscribed rectangles. And if you recall, inscribed are the rectangles that are within the figure. And so based on the direction my curve is going here, inscribed, so kind of lower, they need to be underneath. My rectangles are going to be drawn from the left side over, looking something like such. Okay, notice my dots on the left side will tell you what values we're going to have to use to set up our chart. Let's see, things to do here. I do need to find delta x. And so if you recall, delta x is b minus a divided by n. B and a being our values on our interval. So I'm going to do 3 minus 0 divided by n. So my delta x for this problem will be 3 over n. Now, I'm going to set up the chart. And if you recall, my chart, when I set it up, has 3 columns. The first column is I, which represents which intervals I'm going to use. So you need to go back and look at where were the dots. And I had a dot here at x of 0, x of 1, 2, 3, up until, in this case, my last dot was n minus 1. So my I values are 0, 1, 2, 3, so on and so forth. And then I'm going to go n minus 1. If I had to use rectangles going from the right, then remember this last value might be n instead of n minus 1. My next column, is x of I. And if you recall, x of I, in order to find that, we do our I value from the left times delta x. It's always I times delta x. So my first I value is 0, and 0 times anything is 0. My next I value is 1. Delta x is 3 over n. 1 times 3 over n is 3 over n. My next I value is 2. So 2 times 3 over n. My next I value is 3. So 3 times 3 over n. Down to the bottom, where my last I value is n minus 1 times 3 over n. My third and final column here is f of x sub I. And that is where you take the values we just found in the middle column and we plug them into our function. Our function, again, is x squared. So we're taking each of these values in the middle column and squaring them. So 0 squared is still 0. 3 over n squared, well, I'm going to write it as 3 over n quantity squared. 2 times 3 over n, when I square that, I'm going to write it as 2 squared times 3 over n quantity squared. The next one is 3 squared times 3 over n quantity squared, all the way down to my last one, which is going to be n minus 1 quantity squared times 3 over n quantity squared. Okay, so now in order to set up our equation to find the area, we need to write out our formula. Remember, it is delta x times the sum of your f of x sub i's. So delta x is the 3 over n times your sums of your f of x sub i's. So that right column. So 0 plus 3 over n quantity squared plus 2 squared 3 over n quantity squared plus 3 squared 3 over n quantity squared plus so on and so forth up into n minus 1 quantity squared times 3 over n quantity squared. Okay, now we need some cleanup. First of all, we already have the 3 over n out front. As you look at each of those pieces, they all have a 3 over n quantity squared. So I'm going to factor out 3 over n quantity squared. And then as I factor that out, my pieces left are represented. There's a 0, which I don't need to write. It's not written there, but when I take the 3 over n squared out, there's essentially a 1 left, which I'm going to write as 1 squared. Plus there's 2 squared, plus 3 squared, plus so on and so forth, up into n minus 1 squared. Okay, continuing along, one thing I'd like to do is 3 over n times 3 over n quantity squared. I'm going to clean that up. It's going to be 3 times 9, so 27 over n to the third. And then, if you recall, there are formulas. And there are formulas that represent the sum of squares. So 1 squared plus 2 squared plus 3 squared up to n minus 1 squared. Now, I will tell you, you will be provided as a hint the formula that you will need to use in the test. So you won't have to worry about having the formula memorized. Now, let's see. The formula that we would be provided here is the formula for 1 squared plus 2 squared plus 3 squared, and I'm writing it up here to the right, plus n squared, and they would tell us that that equals n times n plus 1 times 2n plus 1 over 6. Now, in this particular problem, remember, we have to adjust that formula because that formula is provided for n squared. We stop at n minus 1. So if you recall, what I did is every place I see an n, I'm going to replace it with n minus 1. So the first part of that formula is n. I'm going to put n minus 1. The next part of the formula is n plus 1. So I'm going to replace n with n minus 1, and n minus 1 plus 1 is just a plain old n. And then the 2n plus 1, well, that's going to be 2 times n minus 1 plus 1. So it becomes 2n minus 2 plus 1, which simplifies up to be 2n minus 1. Still all over 6. Now, at this point, the best thing we can do is we can get ready for our final step, which, if you recall, is in order to find the area, we do the limit. Okay, so I'm officially thinking right here, I should not have used area right here in this top row. What I should have said is this was the sum, is what we were doing. Okay, we are writing the sum. In order to actually find the area, we do the area, and it's the limit of that expression. So the limit as n approaches infinity of the expression from above. So 27 over n cubed times n minus 1 times n times 2n minus 1 all over 6. Now, as you recall, it's the limit as n approaches infinity. And first of all, notice if we were to multiply this out, on bottom we have n cubed, and on top we would have n cubed. And so it really comes down to that you need to look at your coefficients. And the coefficients that would matter, on top there is a 27, and there is also a 2. So 27 times 2. In the denominator, there would just be a coefficient of 6. And so what I'm going to consider this as is 54 n cubed plus some other terms over 6 n cubed. And remember, when the powers match and we take the limit, it is just the coefficients. So it ends up being 54 divided by 6, which is 9. Since we are finding area, this is 9 units squared. Okay, guys, I hope these videos have helped. Good luck, and catch me on Monday if you have any last-minute questions.